All right, 7.4, properties of special parallelograms. Just a little quick review here. Use a diagram to determine the measure of each angle, right? Well, since these are parallelograms, and you know that because of these symbols, that means opposite angles are equal. So angle 3 is 90 degrees. I just got that one out of the way first. Now, since these are parallel lines and this here is a transversal, that means this angle and this angle are equal because of alternate interior angles. Therefore, angle 2 is 39 degrees. Now, it doesn't ask to find angle 1, but if it did, if these are both 90 and these are consecutive, this is 90. So you would just do 90 minus 39 to find angle 1. All right? And then here, we're only looking for angle 4. Okay? So we know, again, alternate interior angles, number 6 here is 22 degrees. And we have a triangle. Well, we know 125 plus 22 is 147. And if we take 180, because the triangle has 180 degrees in it, minus 147, that gives us 33. So angle 4 is 33 degrees, which makes angle 5 33 degrees also. All right, moving on. So now we're going to talk about rhombuses, rhombi, rectangles, and squares. So a rhombus, similar to a square, has 4 equal sides, but the angles don't have to be 90. A rectangle, similar to a square, has 4 right angles, but the side lengths do not have to be equal. In fact, usually most rectangles have this situation. Okay? And the square is kind of like the perfect ideal quadrilateral because it has the characteristic from the rectangle and the characteristics from the rhombus. So it has equal sides and all 90-degree angles. Okay? So technically, a square is also a rectangle, okay, because it has 4 90-degree angles, and it's technically a rhombus because it has 4 equal sides. All right, let's look at this one. Well, since we know this is 70, we know this is 70 over here. And therefore, we don't have right angles, so it can't be a square or a rectangle, but it does have 4 equal sides, so that makes this a rhombus. Next, the rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides, like we just named the previous shape. The rectangle corollary, a quadrilateral is a rectangle if and only if it has 4 right angles, and the square is if and only if it's a rhombus and a rectangle. In other words, it has 4 right angles and all equal sides. All right, for any rhombus, QRST, decide whether the statement is always or sometimes true. So real quickly, I'm going to make a rhombus, and I'm going to try to make it all equal. It's not really well drawn. I apologize, but work with me here. All right, so QRST. All right, remember, a rhombus is a parallelogram, which means opposite angles are congruent. So Q and S are always going to be congruent. Now, B, Q and R. Well, the only time Q and R, I'll say sometimes, only if it is also a square. So that's the only time a rhombus would have that situation because then they all be 90-degree angles. All right, rhombus diagonals. If you have a rhombus, the diagonals are perpendicular. They form a right angle in the middle there. All right? And then with their angles, a parallelogram is a rhombus if and only if each of the diagonals bisects the angles. So notice what we have here. Let's say B and D were 60 degrees. That means this would be 30 and this would be 30. Let's say C and A were 100 degrees. That means this would be 50 and that would be 50. Okay? So two things happen in rhombuses. The diagonals are perpendicular, so it's still perpendicular here, but it also bisects the angles. All right? Both of those things happen at the same time. All right, find the measure of the numbered angles. Well, angle 1, pretty easy. If this is a rhombus and these are the diagonals, that makes this 90 degrees because they are perpendicular to each other. All right? Angle 2. Well, these are alternate interior angles because it's a parallelogram. Okay, and AC is a transversal. So angle 2 is 61 degrees. But remember, these angles are bisected, which means angle 3 is also 61 degrees. Now, we're going to look to get 4. We're going to look at this triangle right here. We know angle 1 is 90. Angle 3 is 61. That makes 151. Well, if we do 180 minus 151, angle 4 ends up being 29 degrees. Remember, if I'm going too fast or anything, always hit pause and catch up at your own pace. All right, the rectangle diagonal theorem. Remember, a rectangle is different from a rhombus, unless it's a square. So in a rectangle, you can tell this is clearly not 90 degrees, right? So they're not intersecting at, at 90 degrees. They're not perpendicular. And you can also tell this angle here is way smaller than this angle here. So you can clearly see that the angles are not bisected either. That's only for the rhombus. But rectangles have a special situation, all right? A parallelogram is a rectangle if and only if the diagonals are congruent. And as you can see here, they also bisect each other because if this was 10 right here, then this would be 10, this would be 10, this would be 10. And that means this would be 20 and that would be 20. That's a horrible line. Okay, example 4. You're building a frame for a window. The window will be installed in the opening shown in the diagram. First, the opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? All right, so since these are both 33 and these are both 44, based on the measurements alone, not knowing anything about the 4 angles, we cannot say it's a rectangle. All we can say is, since opposite sides are congruent, it is a parallelogram. That's all we know. We can say it's a parallelogram and that's it. You measure the diagonals of the opening. So this one right here and this one right here. One of them is 54.8 and the other one is 55.3. What can you conclude about the shape of the opening? Well, since the diagonals are not congruent, it is not a rectangle. It is quite just simply a little bit off. So none of those angles are 90 degrees. They're probably pretty close, like, 91 and 89, or 90 point something and 89 point something. It's probably really close because these measurements are pretty close for the diagonals, but they're not equal. We would say that that thing is not square. Not the shape square, but whenever you have right angles, we call it square. And that opening is not square. In rectangle, QRST, QS is 5x minus 31. So that's this diagonal right here, 5x minus 31. And RT is 2x plus 11. Find the lengths of the diagonal. Now notice, in these directions, we're not saying find x. So first off, we know they are equal to each other, so I just set this up. I'm going to keep my x's positive, so I'm going to move this over here. I'm going to add 31. That cancels, that cancels. I end up with 3x, 5 minus 2, equals 42. I'm going to divide by 3, and that gives me x equals 14. I am not finished. It did not say find x. It said find the lengths. So what I need to do now is plug this in here or here. It doesn't matter. They're equal. I'm going to plug it into the smaller one here with addition. So 2, I don't know why I put an x. 2 times 14 plus 11. So that's 28 plus 11, which is 39. So they both measure 39. If you want to do 5 times 14, subtract 31, you can, but you will get 39 for both. And our last example. Decide whether ABCD is a rectangle, rhombus, or square. So negative 2, 6. So 1, 2, 1, 2, 3, 4, 5, 6. 6, 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be off a little bit. C, 4, 0. 1, 2, 3, 4, 0. And D, negative 4. 1, 2, 3, 4. 1, 2 down. That's D. So okay, even though you can clearly see that this is not a square, it's not 90 degrees, we still need to do the slope just to prove it. So the slope of, let's say, I want to stay on the graph, so I'm going to do AD and DC. So AD, if I start at D, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, up 8, right 2, which equals 4 over 1. That's a slope of 4. To be a right angle, DC would have to be negative 1 over 4. Well, for one thing, you can tell it's a positive slope. All these are positive slopes, so it's not possible. But let's go from D to C. I'm going to start D and go up 1, 2. And go right 1, 2, 3, 4, 5, 6, 7, 8. And that's 1/4. So they are reciprocals, but they're not opposite reciprocals. So we know AD and DC are not perpendicular. So it is not a square or rectangle. Now, if we were going by elimination, we know it's a rhombus. But if we wanted to prove that it's rhombus, we have two choices. We can do the distance formula on all 4 sides, and that would prove that all 4 sides are equal. Okay? But we don't have to do that. A shortcut would be, remember, the diagonals AC and BD need to be perpendicular. So if we just do the slopes of those two, we can prove that it is a rhombus. So AC and BD. So real quickly, I'm going to count from D to B. And it's going to be up 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, we went off the grid 10. And then write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 over 10, which is 1. And then AC, I'm going to go from C, I'm going to go up 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5, 6. And that's -1. Well, that is opposite reciprocal. So, since the diagonals are perpendicular, it is a rhombus. So again, I could have done the distance formula on the sides, but honestly, that's more work, so I'm just trying to be efficient with my time. And that's it.